Hey everyone, in this video we're going to go over the Octane object parameters, so the settings that you will find under the Octane tab when selecting an object in Houdini. Hey, Dom from the future here. This turned out to be kind of a long video, and so I'd highly recommend if you're here for a specific piece of information to just use the timestamps and jump ahead to the section that you're interested in. Otherwise, we're going to go through all of the settings one by one, and hopefully this will be a great starting point for people that are getting started and just want to know everything. Otherwise, you can just use it as a resource and jump to whatever you need to know about and just come back to the video as necessary. So admittedly, this is kind of an awkward time to record this because we're right in the middle of revamping the object parameters and making them a lot cleaner and easier to use and hopefully less confusing. And decided I'm going to show the settings on the new 2026 setup. So this is going to be a future-proof video. However, I'm going to go over differences here in the beginning so that you'll be able to maneuver either the older or the newer versions pretty easily. In Octane 2025 and before object properties, you can see that we have all these different tabs. And one thing we want to do is to make this whole object experience a little more context aware. Because for example, if you work on volume, most of these settings aren't necessary. You only need really one tab and some of those properties and the light pass mask, for example. Or if you're working on geometry, then some of these other ones don't make sense. And so one big change we made in Octane 2026 is that we now have this object type setting up here. And here you can basically select what kind of object it is. Is it a volume object? Is it a geometry object? Is it a Gaussian splat? And based on that, it basically hides or shows tabs that are relevant, and that should hopefully make it easier for new users, but also for experienced users to not have to dig through the clutter and be able to just see what they need to see for the given object type. The other thing is that while you had some like object type specific settings, you also had other more like property type settings in these tabs, and we wanted to help with that too. So we moved a lot of these properties into the properties tab with some drop down. So for example, where the light pass mask before was this long list of checkboxes, we now made that a button strip, so it takes up less vertical real estate. We also put it into the visibility settings. It belongs, I think, alongside with the trace sets that are coming in 2026. And so quite a few of these settings are kind of tucked away here, and hopefully should make more sense and make just accessing everything easier. But yeah, just know the same settings I'm going to be talking about for the most part you will find in Octane 2025 and before as well. However, the organization might be a little bit different, where some of these things are in the drop down here, some of those elements will be up here in the tabs, and then of course there's some new features like the trace sets and Gaussian splatting and Meshlets that are coming in 2026 that you won't find in 2025, so just be aware of that. Also in Octane 2026 we added descriptions to pretty much all of these, which hopefully also will help some of the user experience. Okay, so let's go through the settings one by one. Object layer ID, this is used when you're rendering with object layers. That's where you set your object layer. Object layer color is used when you're rendering with the object layer color AOV. We have a custom crypto map name. So if you're rendering with the object node name and maybe the geometry node name, then you can set a custom name there if you want it to be different from what Octane automatically generates, which I think is based on the object name. And then random color seed is if you're using the random color node. Then the visibility settings, this top button just completely hides an object from the render. It's completely just ignored and not loaded. General visibility applies basically like alpha to the whole object. Camera visibility hides it from the camera. Shadow visibility hides it from the shadows. Dirt, curvature, and rounded edges visibility basically stops the object from affecting those nodes in the shader. So then we have the light pass mask. And this allows you to exclude certain lights from affecting the current object. So for example, if I disable light pass 1, now you can see that this light up there no longer affects the block. Or if I turn off the environment light, the S stands for sun, the E stands for environment light, which is like your H or I or whatever. You can see that this no longer affects the object. Okay, so next we have the trace sets. And this is an incredibly powerful feature. In some ways it can work like a light pass mask, but it's even more powerful than that. So first of all, you have the trace sets parameter, and this is where you set the trace set or the multiple trace sets that this current object belongs to. In this case, I just have a trace set called block. Or for example, up here, I have a light that's part of the lights trace set and an overhead light trace set. And so let's say, for example, I want this light to be excluded from affecting my block here. So I can add a visibility rule and call it overhead light. how did I spell this? Overhead light. Be aware that this is case sensitive. And so now you can see that this overhead light no longer affects my block. If I add a minus before it, this now kind of inverts that. The only thing that affects this object now is the overhead light. Now what's really cool is that this whole trace set thing is not just limited to lights, but it also lets you affect how geometry shows up on bounces of other objects. So for example, let's say we add this reflective surface at the bottom, but let's say we don't want this block to show up in the reflection. We can add a visibility rule on this ground object, and we can exclude the block. And now you can see the block is no longer there. Let me add another object here to kind of show off some of these other settings after that. So currently you can see this block shows up in the reflections back here, but not in the one in the bottom. So let's say we want it to be to not show up in the reflections down here, but we do want it to show these reflections in the wall to show up again. So basically hide it from the first bounce, but then show it in the bounces afterwards. And so for that, we can set this to next hit only, for example. And now you can see that while the direct bounces are excluded, the other ones aren't. Or the flip side of that is, say, all future hits after the next hit. So that means the next hit, it's still included. In this case, you can see it's still there. However, the reflections after that, so in this case, the light bounces off the block into the glass, and then on the ground you can see it's no longer there. So these are kind of like the inverse of each other. And then another way you can control this is by, on this back object, we can say let's re-include the block if it was excluded earlier. So you can see that while it's excluded out of the direct hits here, we re-included it through this. So this kind of gives you very detailed control. I don't know how often you'd actually need all these settings, but it's really nice that we have these options. Okay, next we have the geometry settings. So up top, smooth angle basically defines if there's not normals present already on the geometry, at what point basically we have a smooth transition or sharp one. So in this case, I have this bevel up top. And if I turn this down, you can see that when it's less than 45 degrees, you can see now we have a sharp edge. If I turn this all the way down, you can see that pretty much now all the faces are sharp. So when it comes to the tessellate end-on sections, I just added this hole to the tube. And if I disable this tessellate end-ons, you can see that this disappears. And that's basically, when you enable this, it will triangulate all your end-ons, and so it will render correctly. Sometimes if you have big end-ons that kind of have concavity to them, that won't render correctly. In Octane 2026, that is going to be on by default. However, in older releases, this is not on. And so just, if you have a mesh that's not triangulated, and you're running into issues like that, you probably want to turn this on. Then this next bit here, render as tessellated object, this comes into play when you're using non-polygon surfaces, for example, NURB surfaces. So in this case, we have a NURB surface, and this basically defines kind of the resolution of when it's converted to polygons. So again, if we switch here to our wireframe preview, you can see that as I change these subdivisions, we can see that the resolution of this mesh changes. And then we have the subdivision level, and this is exactly what it sounds like. What's cool about this is that this subdivision happens in the GPU. So the geometry that we're loading into the GPU can be a lightweight mesh, and then we can add subdivision to after. These settings, they change how the subdivision happens. This bottom one is important if you're subdividing a triangulated mesh. So let me, for example, swap out here a sphere that uses triangles, and we look at our wireframe, you can see that we have these kind of patterns to it. So if you have a triangulated mesh that you want to smooth, you might want to change this to loop. And this does a more appropriate subdivision when it comes to triangulated meshes. And I'm not really sure what the bilinear is for. I guess it's kind of like Catmull-Clark, just without smoothing anything. Next we have our meshlet settings. So meshlets are a new feature coming in Octane 2026. And it's comparable to Unreal's Nanite. And basically what happens is when we enable this, Octane is going to process this mesh and generate what you could call a meshlet mesh. And this is an optimized mesh that will change its basically resolution or density of the mesh based on its visibility on camera. So if something is close to the camera, it will have more polygons, and as it moves away from the camera, it will be reduced more and more in polygons. And so this is really a powerful feature for really heavy meshes. So think of your mega scans or your 3D scans meshes. those sort of things. So in this example, we have this really high density scan of these two dogs. And if we look in here, we have over 1.2 million points, which is not insanely heavy, but it's pretty decently heavy. And currently, if you look at the scene memory, we have about 3,927 megabytes used. And so now if we enable meshlets, you'll notice two things. One, Houdini will freeze, and depending on how heavy your mesh is, it might freeze for a minute or two. Maybe even more if it's a bigger mesh. So proceed with caution when enabling this. What the system is doing right now is actually processing this mesh and generating this meshlet. And so we're going to wait until it's fully processed, and it's probably going to be around a minute and 10 seconds. All right, here we go. The scene has been processed and we can see it refreshed and it's sampling. If we look at the memory, you should see a difference that it's a little bit lower. Depending on your mesh, it might be a lot lower. One thing that's interesting is when we zoom out, we can see that our scene memory is actually getting smaller. And as we're zooming in, you can see that our scene memory is increasing. And if we go into render target under AOVs and enable our wireframe pass, we can actually kind of see a little bit what's happening, that like the density of this mesh is changing slightly as we zoom in and out. And yeah, it's kind of hard to tell, but there's definitely something changing in the density. And basically, as you zoom out, the mesh will get coarser and coarser because it uses less of the screen space. And here in the render target settings under the kernel, we actually have an LOD bias section. And so this basically determines how coarse or fine these meshlets are going to be displayed. So if we turn this down, we will see that the mesh will get coarser and coarser. And on the flip side, if we turn this up, the mesh will get denser and denser. One other benefit is that with meshlets, if I hit refresh, we should have a pretty quick loading time, at least compared to the original mesh, as the meshlets itself are much faster to load. The only thing is that basically on this first time it loads, it's going to be much longer. If I were to go in here and like change some value, for example, I have this noise going on, and so let's say I change this to something like really high. Let's let this run for a second. And you can see we have this crazy mesh here, but nothing is changing in the viewport. And that's because we decided to make the updating of the meshlets a manual step, because every time you update a meshlet, it can take a minute or longer to load. And so we figured that would be pretty annoying trying to make changes without having to completely stop the IPR. And so we decided that it would be best for users to just manually have the option to basically update the meshlet as needed. So what I would generally recommend is if you're working on a mesh and modifying it, you might want to keep this off and then turn this on when you're ready for basically production, and when you have most of your changes done. Obviously, if you do make other changes, you can just hit this update meshlet button and it's going to update it. And if you're an advanced user, the way the meshlet update actually works is that we're creating this meshlet ID based on the file path, the operator path, and then this version number. And this basically creates the ID. And what Octane does is every time the ID changes or it doesn't find the ID of this mesh in its current like mesh cache, it will rebake the meshlet. So if we hit the update meshlet button, what will actually happen is that this number will just increase by 1 and thus changes the meshlet ID, and thus a new meshlet will be created. What this means is that, for example, if you for some reason wanted to create a meshlet animation, which is not possible by default, you could just add a frame variable into this meshlet ID, for example, $F, and then you would be able to bake a meshlet animation, so to say. However, for each frame, it would have to run for like a minute or so. And obviously, if you're trying to play back the animation on the timeline, that would be pretty much impossible. But what you could do is you could run a render, or even run a very basic render, just an info pass render, to force it to like bake out all these meshlets. However, do keep in mind that I think the meshlets do take up quite a bit of space in your system. And so we can see that now this meshlet has finished baking and we have this weird new meshlet. And if we change this version number back, actually we should be able to see our previous version load again. Whenever we update the meshlet, it jumps to the next number, and if it finds the ID, it will load that. Otherwise, it will create a new meshlet. One other note in terms of managing the cache: if you go up here to the Octane options and then under file caching, you will see cachelet mesh size and then option to clear the cache. So if you want to, you can clear this, and that will basically wipe all the meshlet cache off your system. All right, let's talk about the instance settings next. So this first setting, packed geoinstancing, basically tells Octane, hey, I have packed primitives in here, and I want you to read them as an instance and not as one big mesh. So currently this is disabled. So Octane is just reading all of this as one big mesh. And if I reload the scene, you will see that this takes a minute to reload because it's reading all of this as one big mesh. However, if I enable pack geoinstancing and reload, you will see that this should go much faster as it's actually reading all of these as instances of the same object. And all I'm doing inside is just packing the object using a pack node. So for this next setting, if you enable this, it basically will allow you to give a custom velocity attribute to an instance instead of Octane calculate it on the fly. So let's say we're animating these instances. So let's give them rotation. So I'm going to write an expression here, $ff by 180, and you can see that we have this beautiful motion blur. And by the way, if you're doing rotational motion blur like this, you definitely will want to up your motion blur steps, because at their default, at 2 in this case for instances, you will see that things don't look very good. So we want to up this in this case so that we have this nice, beautiful rotational motion blur. And Octane does a really good job of generating these motion vectors for us. And the cool thing is that, like in this case, this supports subframe motion blurs. So what we have within one frame, this rotation, using these samples, it can actually calculate kind of the in-between steps and create these beautiful, beautiful motion blur. However, in some cases, you might want to be able to give your own velocity attribute. And just keep in mind that currently Octane doesn't support a rotational velocity, just a directional, at least the Houdini plugin. So I have a velocity vector on here, and now if I enable instance motion blur computed from velocity attribute, you can now see that they are reading this attribute instead. So if I change this number, for example, or I change the seed, you can see that we get like a really pretty funky result. And then this setting here, ignore pivot point attribute, won't really matter in most situations. But let's turn this off. And then I just added an attribute here called pivot. And now if I change this value, you can see that the pivot is not at the origin anymore. And so this might be useful for certain situations. In this case, we're kind of creating a cool little abstract shape here. Now we have these custom AOV settings. And so if I go into the Octane render setup under AOVs and enable, let's say, the custom 01 pass, and then I add this object to the custom AOV1, you can see that now I have basically a mask for this object in my custom AOV1. I can change to what channel I want this to go to. So if you want to put multiple objects into the same AOV or just on different channels, you could do that here. Okay, let's quickly talk about the baking settings. Unfortunately, there's a bug in the current version of Octane Houdini that I'm using. This has been fixed in later versions, but I can't demonstrate it inside of Houdini right now. So I will show you how it works in standalone. But basically, these baking settings work when you're using the baking camera. This is our object we're going to bake. And so if I switch back to now the baking camera, you can see that it basically is baking down the object's textures to the UV map that the object has. And so this baking group ID basically just selects what group ID it shows up in. So if we look here on the camera, we have a group ID, and then we have a group ID here. And so, you know, any objects that are in baking group ID 3 are going to show up if I were to hit render. So in this case, if I were to move this box into group ID 1, now it doesn't show up anymore. And then these UV settings just allow you to basically rotate and move around your baking object in UV space. All right, so next let's talk about the attributes tab. And this is something that we've worked on and will continue to work on to improve and make easier. And I think this is a common subject of confusion to people, how this works. And so I will probably make a separate video on this as well, but I figured I also will mention this here on how this works. So there's an important distinction to be made between geometry attributes and instance attributes. You will see here on the left, we have a single box that has color on it, right? So there's color applied to the different points or vertices of the object. And so this kind of attribute uses the geometry attribute. Now, what's important to note is that, you know, if I were to make a whole pile of these, they would all look the same. This is not like different for each instance. The instance attributes on the flip side are like one single value for each instance, right? So in this case, we have like a pile of like 10 or something boxes. And so each one of those has a different color. Now you couldn't use instance attributes to apply a gradient to this box like this box is. That's the difference between the two. That's something important to note, and they both have different workflows. Let's make the geometry attributes work first. So if we dive in here, we can see I've applied this material and I've applied a color attribute. So the first thing we have to do is under the attributes panel up here under geometry attributes, we will add CD under point vector attributes. And depending on if your attribute is written to points or vertex, you choose the top or the bottom. Do note that primitive attributes are not supported. If you want to use primitive attribute, you will have to promote it to vertices first. And then we go into a material that we've applied here. To use geometry attributes, we will want to drop down an color vertex attribute or a float vertex attribute if you used the float. But in this case, we use a vector, so we're going to use a color vertex attribute. And then we have to write the same value in here, so in this case CD, and then we can plug this into, let's say, our base color. And we can see now that the attribute is coming in and we have the color coming into our render. Now, another thing to mention here is the rest position setting. So if you're using, for example, triplanar projection or box projection or some of those other projections that support the rest attribute, you want to turn this on. And then by default, it's looking for rest position attributes. So the way you would probably add this is using the rest position node before animating it. And that way you would get the projection to basically stick to deforming geometry. Another option is to use this rest position by frame. In this case, Octane automatically creates this rest position for you. However, keep in mind this only works if the geometry is stable. So, if you're having some kind of remeshing happening, like a fluid simulation, then of course this would not work. Now, what about instance attributes? Those work a little bit differently. So if I go into the instance attributes geometry in this case, we can see I have our object. I'm applying the material. I'm copying and using the copy and transform node using the pack and instance. And then at the end, I'm applying the color to the pack geometry. So this is actually on the instance point basically. So now to get this to work, for one, we're going to go in our instance attribute material and we're going to drop down the texture instance color node. And we're going to plug this into our base color and we can see that now our item turns black. And that's because we haven't applied an attribute to it yet. And let's also name this just for organizational purposes so we can find this well. And then in our object, now under instance attributes, we will add a new list item. And then we point this to our color. If we click this little triangle drop down, we will see that automatically gives us some options here, and we can see the CD node that we just created. However, you can also click here and find this. However, it's important that it's a texture instance color node. And so we applied this, but that's still, they still are black. And why is that? And that's because we have not enabled the pack geo instancing under the instancing settings. Right now, this is just reading it as normal geometry. So we have to enable this. And now you can see we get our beautiful colors in here. Now, one quick note, you can also use the instance node, and this current version does not automatically add the Octane properties to this. We're going to change this in a future version. However, if one of your objects for some reason is missing that, you can add that using the object params button up here. And so you can do the same thing with the instance attributes with an instance node. However, you don't need to select the pack geo instancing because if you're using an instance node, it's already recognized as an instance. Other than that, it works the same way. You can add your point attribute here, etc. A few more notes on these bottom settings. So the object level instance ID, this matters when you're using the user instance ID AOV. And then this last setting, instance IDs from, by default, this is point number. And as of this current version, if you're wanting to use instance attributes, you have to leave it that way. And this means that it just uses the instance point number as the instance ID. This matters for one, for this texture instance color, but also, for example, if you're using the random color node or like the instance range or highlight node, those also use this instance ID. The thing is, in certain situations, for example, if you have like a particle emission type setup, you might have unstable point numbers. And so if you're using the like random color node, for example, as particles come in and out and the point numbers shift around, so will this random color node. And so in that case, you might want to set a custom ID attribute, or maybe if you're using a particle simulation as a base, then it might already have a custom ID attribute to set the instance ID. And this will fix things like the random color to where they're not shuffling around. However, as you see, as I enabled that, we no longer have our instance texture working. The way this whole instance attribute works is that it creates basically a texture with a pixel value for each instance. So the first pixel in this texture would be the color of the first instance, the second pixel in the texture would be the color of the second instance. And so it's using this texture map to basically save these values and then display them later. The problem is that if you're using IDs where the numbers might not be 0, 1, 2, 3, but further in the particle simulation, the ID might be 2000, 2001, 2002, it would have a bunch of empty pixels. And so currently this is not supported. However, we might look into making this ID point attribute working with this texture instance color. So basically, if you're having unstable point counts, you can't really use these both together, the texture instance color and the random color, because it'll be unstable. So in that case, you might want to just generate random values as an instance attribute. So basically doing the random color in SOPs and then loading it in through here. There's a third setting here called packed RGBA values from CD point attribute. And this one works again another way. And so instead of writing a texture map and then reading it back, this actually basically encodes the color into this instance ID. And this also will break the random color node. And it works a little bit different because instead of automatically applying this here, you actually will want to use this RGB 4K map, and this should actually be there by default. And so usually if you enable this, and as long as you haven't changed the default, which I think I might have, and you plug in a texture instance color node, this should automatically work. Just keep in mind this only works with a single RGB value, and so you only can have one of these attributes per instance. So we've gone through all the settings for normal geometry. So let's start with the first one that is kind of a different type, and that is particles. So in the new object parameters, we select this particle objects type. And you can see now we're actually seeing something here in the render. However, if you were still on an older version, just note that to enable particles, you'll go under the particle tab and press this button. In the new version, this is all handled by this object type. So we set this to particles, and we can see that immediately something is being rendered over here. There's a new tab called particles, and here we can set the default radius. So if there's no p-scale attribute, which in this case there's not, we can set the overall size of the particles. And then on top of that, the bottom one applies if there's a p-scale attribute set and you want to just globally scale the particles down or increase the size. Now let's go inside and let's actually add a p-scale attribute here. So let's do attribute adjust float, and I'll add in here. By default is a p-scale, and you can see now the particles are gone because the value right now is set to 0. So let's set this to a noise, and maybe we'll set the maximum to 0.01. and the minimum to let's do this 0.01 to 0.05. And then maybe this is still too big, so now we can scale it down a little bit more using the bottom section here. Okay, so obviously that's working now. Now we want to create a material, so let's just create a new Octane material builder, and we're just going to drag this to item, and then in here we have our material. So let's get these colors into this object. On one side, there is the settings back here, packing color and alpha attributes into the UV map. And that is one way to do it. However, there's a better way, I think, to do this, and that is just using the geometry attributes section and using the vertex color attributes. So let's add here under the point vector attributes, let's add CD. That's the color attribute we have on this geometry. If you look in here, we can see that the color attribute CD. And then in the shader, we just add the vertex color attribute. We plug this into our base color in this case, named it CD. And here we go, we have our colors coming in. Or if we want a more of a glowy particle, maybe we want to plug this into our emission color and add some emission. And then there's this other alternative to use this pack color and alpha attributes into the UV map. And so if we enable this, we can use this texture that ships with Octane, and using the UV and W map, it will look up the color and the alpha. So the color is encoded into the UV space, and the alpha attribute will be encoded into the W space. And so the way we get this to work is, for one, let's go into particles again. Let's duplicate this p-scale attribute node. Set this from 0 to 1, and let's call this alpha. And so we should be able to see here in our viewport if we change these values, we can see like how this affects our alpha value. So maybe we set something like this, for example. And so now to bring this into the shader, we go back up, we add the name of the attribute, which is alpha in this case. And then in our shader, we will drop down 2 texture image RGB nodes. This first one will be our color. And so we're going to plug this one into the emission color. And then we have to look up a very specific texture. So if we go into the file browser and we type in $OCT version, we get to our Octane installation folder, and then there under TEX, you will find 2 texture maps. And so if we load the RGB 4K texture map, now we get the color. And then to get the alpha, we have to duplicate this and plug this into our opacity. But this time, instead of picking the RGB, we'll pick the alpha map. And now you should be able to see that there's something changed with the visibility. And if we modify this value here, this should become even clearer. So if we move this around and, like, for example, make even more of it invisible, we can see that this is like correctly displaying in our render. And then one other note when it comes to particles is for motion blur, you'll want to go in here, and if your particle simulation isn't already putting out a velocity attribute, you will want to add one using, for example, the point velocity node. And now you can see we have wonderful motion blur in here. Next we have fur, and the way fur works in terms of attributes is the same way as particles work, or you can use either the geometry attribute section or pack it into the UV map. So it's the exact same thing as we went over just for particles. And then the curve root thickness is basically the thickness at the bottom of the curve, at the beginning of the curve, and then the thickness at the tip. And this hair gradient interpolation really just determines how this basically fall off happens. Does it happen by length as like a linear fall off, or is it per section and each section gets smaller? And so if you had like a lot of sections in the beginning and then less at the top, then it would like move around how basically this thickness is distributed along the curve. Okay, next we're going to talk about the Octane scatter object type. And unfortunately, in this current version, this feature is not working. However, this should be fixed pretty soon. But in the meantime, I will show you how to set this up in Houdini and then show you how it works in Octane standalone. So first of all, we have 5 different parameters here. And the top one, the scatter VOP node, you want to point this at one of Octane's 2 scatter nodes. So if we go here into the material context, we're going to drop down this scatter on surface and the scatter on volume nodes. So you basically drop these down, whichever one you want to use, and then in the scatter options, you want to point the scatter VOP node at either scatter on surface or the scatter on volume type node. So let's do this scatter on surface, for example. And then we can select our 4 objects that we want to scatter on top of our geometry. So in this case, I might select, I don't know, like maybe I have like a little box or something. And so I would select like a box or, you know, multiple objects that you can scatter. And then in here you have all these different options to basically set how scattering works. And we're not going to go into detail on this, but generally that is how you are going to set it up. Now the surface that the scatter is going to use is going to be whatever is inside of this object. So in this case we have our pig head, but what's a little bit different is scatter on volume actually doesn't use any kind of like geometry input. And I'll show you in a second in Octane standalone how this works. We're in standalone, and I just want to show you real quick how these 2 different scatter types work. So we have scatter on surface, and for this we're going to plug in our pig head in the first input, and in Houdini this will just take whatever input is in the node that you have the scatter object enabled. And then we're going to plug the scatter on surface in, and right now we just have this like placeholder box, but we have to add something to scatter. So in this case I'm just adding this box here, and you can see that it copied all these boxes to the vertices in this case of the input. Now I can change the settings here and can, for example, change it to be like random. But yeah, there's all kinds of settings here that we won't go into in this video. And then scatter and volume, it does not take a geometry input. So basically whatever's in the node in Houdini is going to be ignored. It just takes like basically scatter items. It's basically scatters it to like a grid, and you can like, you know, change the offsets and change the numbering there. For this case, we're making like this big grid of just boxes, and you can do things like offset the positions, for example, and all kinds of stuff. So I'm not going to go much more detail here. This is beyond the scope of this video, but this is basically the results you will see whenever the scatter object is working correctly. Then we have the mesh light. All this does is basically just apply an emissive material for you and kind of like give you all these emission settings right here in the UI for easy use case for mesh-based lights. All right, next we have the volume type and the VDB file type, and they're mostly the same. The big difference is that the volume object type gets its data or volume directly from inside the Houdini node. So if you're working with like a volume simulation and you want to display it directly, you can use the volume option. Otherwise, if you're baking out to a VDB file or you're using a VDB file stock asset, then you can use the VDB file object type, and then you will have here a field to select your VDB file. For this example, I'm actually going to just work in the VDB file type because there are some issues in the current build with the volume type. For example, the density slider for some reason and the shader isn't working correctly, and also getting a color grid into the render is not working correctly. So I will just work with this VDB file. However, one thing I do want to note when you're working with the volumes directly from within Houdini is that Houdini has basically two different like volume grid formats. You can see this one here says VDB volume. However, if I drop down a convert VDB node and set this to volume, now we can see that this instead says one grid volumes, and also this icon is different. And that's because one of them uses the VDB format and the other one uses like Houdini's native volume format. The big difference is, one is that the VDB actually supports vector grids. However, when we convert this to a Houdini volume, you can see that now everything is split out into these components, so color XYZ and velocity XYZ, and that's because Houdini's native volumes don't support vector grids. So that's one big difference. The other big difference is that a VDB can turn off sections. So if we think of this as a box that contains all the volume data, VDBs can actually turn off sections that are empty and thus are more efficient to store. That being said, however, in the current build of Octane, and this is hopefully something we will improve in the future, if you're using the volume setting where it's importing the data from inside, for some reason loading a Houdini volume is much faster than loading a VDB volume into Octane. And this is when you're using the volume option that loads it from inside the node, not the VDB file. So just something to keep in mind. Hopefully this is something we can improve in the future as we kind of resolve some of these other issues as well. But in the meantime, this is something to be aware of. So depending on what format you're using, for example, for velocity, you might have a velocity x, .y, and .z grid, or if you're using a VDB file, you'll just have a single velocity vector grid. Okay, so having a basic volume like this that is just, basically a cloud or dust or something like that, that's just a single color, is pretty much as easy as just using the default settings. And then here in my volume material, I just have a medium standard volume plugged into the medium pin, and I just modified a few settings here to make it look the way I want to. But basically, you should be pretty much good to go from the get-go. You can change your single color just using the scatter color parameter here. But let's say you have a volume object that actually has colors like in the volume itself. So let me pull up this other example here. And again, I actually wrote this out as a VDB file, and we're going to refresh. And as you can see, we're loading this volume file here, but the color is not currently coming in. And for this to work, we have to do a few things. For one, under additional grids, we have to load in the color grid. And this grid is just called CD in this case, which is like the Houdini standard for color. And so we're going to add this here. And then for it to actually display in the shader, now in our medium standard volume, we have to add this here under the scatter color channel. So I'm going to add CD here, and we can see now we have our color loading. So, you can bring in other grids here and then use them in the shader in these different channel sections. For example, if you wanted to use one for transparency or use one for emission, you could add those here. One other thing is, let's say you have a velocity grid. In this case, we also have this here, and you can see this is a vector grid. So to add this, I just have to here under the velocity grids add VEL. And after refreshing here, we should be able to see that there is some motion blur happening. After adjusting the settings a little bit, we definitely can see that there is some motion blur going on here, especially as the render is clearing up more and more. Now, one other thing that's important to note while we're talking about volumes is that if you want to bring specific color in, you have to use the medium standard volume, where you can manually set the different channels. However, there's also another workflow to use a medium volume, which is the original volume workflow. This one works a little bit differently. You can't directly give it any specific specific colors, but you can use basically these absorption, scattering, and emission grids that you set here, and then use a volume ramp to basically remap the volume color based on any of those values. So basically you can map it to where dense areas of the grid are a different color than less dense areas by plugging this into like the scattering ramp or something. Finally, one last note is we do have this other kind of volume called SDF, and SDFs, or distance VDB is how it's called here in the VDB from polygons node, which is usually called surface, is a volume that describes a surface instead of a fog. And we can also display this. I'm just going to go back here to the volume setting, and if I set this to SDF and then set this to surface, which is the name of our SDF, we can now see that we're actually rendering a surface instead of a volume. So that's another thing that is accessible to you. All right, next we have Vectron. And the Octane core team has done a lot of work with Vectron to add a lot of really cool functionality with SDF surfaces and different combination methods. However, this is currently not yet implemented in Houdini. We have plans to do so very soon. But in the meantime, all in the Vectron toolset that's available at the moment is the Vectron OSL. And so if you select Vectron here, there's an OSL Vectron VOP node parameter. You can head into any kind of material VOP context and drop down a Vectron OSL node. And so to use this, you need a Vectron OSL script. Obviously, you could write your own. However, I don't know how to do that. But as part of your Octane subscription, if you go onto the downloads page under asset packs, there is this thing called Machina Infinitum. I don't know if that's pronounced correctly, but they have all these like Vectron packs. And if you look on their website, they're basically these really cool abstract fractal type geometry scripts. Here we in the Vectron pack 3 folder, there's a folder called formulas, and in there we'll see a bunch of different ones. So in this case, I'm going to load the boxbrot.txt. But now if I open this and I click compile and build GUI, and then I have to assign the Vectron OSL node here. But then once we hit refresh, we should see this kind of cool fractal going on here. So let me scale this down. And you can see that they have this incredibly like complex geo created by this OSL script. And in this case, there's actually a bunch of like different parameters that we can use to kind of like modify these. But yeah, so currently that's the extent of Vectron. However, hopefully very soon under the same tab, you will see a bunch of extra settings, and we're going to be working on a whole Vectron toolkit in SOPs that will work with this as well. So keep your eyes peeled for that, and we're going to make a video whenever that's released. Okay, and then finally we have our Gaussian splats. If you don't know what Gaussian splatting is, I would highly recommend you to go on YouTube and look it up. It's a really cool technology, but Octane now officially supports it natively. Another thing that I'll mention here real quick is GSOPs, which is a free open source plugin for Houdini that allows you to work with Gaussian splats and unlocks all kinds of cool things. So I'd highly recommend checking that out too. And the Octane Gaussian splatting implementation is actually compatible with it, which I'll show here in a second. Okay, so there's 2 modes that we have. The first one is a .ply file, and in this case we can just load a .ply file, which is the kind of file you usually get when creating Gaussian splats or when downloading Gaussian splats online from places like Polycam or generating it with software like PostShot. And so in this case, I'm actually going to load an example file that comes with the GSOPs plugin. In this case, let's load this Christmas tree. You can see we have this cool Christmas tree, and if we move the camera around here, we can see this is like a 3D representation, and it's actually quite detailed. But what's interesting, if we go close to it, we can see it's actually not made up of polygons, but it's made up of these like individual little circles, like blurry circles called Gaussian splats that make up the geometry. But what happens when you zoom out, does a really good job at accurately representing things, and as opposed to polygons, it actually is pretty good at like representing little things like grass, or in this case the needles, which is pretty cool. So in the settings here, for one, we have this flip axis setting. Sometimes when you load in a Gaussian splat, it's going to be upside down, and you can use that to flip it up right side up. You can tint it. This convergence bias can help render some details better, but it will affect the performance a bit negatively. And then convert to scale basically seems to like scale up or down these splats. And then intensity, I think, is basically like the emissive strength almost. So if we turn this all the way down, there's like no brightness to it. And then obviously we turn it up, it's much brighter. Then we have our shadow strength, and this is how much shadow the Gaussian splat receives. And I think a good way to combine this is with this lighting mode. So by default, the Gaussian splat doesn't receive any light. So if I turn on this light over here and put this right up next to it, even if I turn this up like really high, the Gaussian splat itself doesn't receive any lighting. However, if I turn this to power or power and color, you can see that now it actually receives lighting. We can see this is quite bright. And this is where I think the shadow strength comes in. So if we turn this on again, we can see that this now actually like receives the sunlight from the other direction. We might want to turn the intensity down to kind of compensate for it, and now it actually looks like this object is kind of being lit by the sunlight. Or over here, this other light, we might need to turn it up a little bit more to make this more obvious. But yeah, you can see now this object is actually casting light onto it. If you disable the shadow strength, then basically it doesn't cast any shadows on itself, and on one it casts full shadows on itself. And then power and color just means, does this receive just intensity from the lights or the color too? So if we turn this light like a blue, you can see it receives it. However, if we turn this to just power, it only receives brightness and no color. Now to show this off a little bit more, I load this other file from an old castle, and then you can see how cool it is to see other objects kind of interacting in this environment. And currently all the lighting here is disabled. So if I go and turn on power and color, and then I give it shadow, and I turn the intensity a little bit, we can see that now this Gaussian splat is actually like fitting into our scene and is casting shadows. It's receiving shadows and it's casting shadows, which is really, really awesome. So if I turn the sunlight around, you can see that it's actually very much integrating into the environment. So let's talk about this other mode called Splat Geo. And so we select this, we can see that this file path disappears, and now we have a new checkbox here called GSOPS compatibility mode. We'll get into that one in a second. But let's dive inside and let's drop down a file node, and we're going to open this Christmas tree file again. We now see this points in the viewport, and we also see it rendering. And so what this mode does, it basically, instead of using a PLY file, it actually takes the data from an imported PLY file that Houdini natively supports. And so you can see if we, for example, now use a transform node and scale this up and down, we actually see this update in real time. One of the things though is that Houdini by itself does not correctly like scale up and down the data that comes in with these Gaussian splats. And as you can see, there's all these different attributes that come loaded in with a PLY file. And that's where GSOPS comes in and makes things a lot more usable inside of Houdini. So I have GSOPS installed. You can find resources on how to do that on the GSOPS GitHub. But I'm going to load Gaussian Splat import node. And this is a GSOPS node. So if you don't have GSOPS installed, you won't find this. And now I'll do the same thing here. We'll load the Christmas tree. And as you can see, it loaded it, but we don't have anything visible. And that's because GSOPS actually converts these Gaussian splat attributes to something that's a lot more usable, like color and orientation, scale, and these SH coefficients, I think, are the main ones. And so now if we go back out and now we enable the GSOPS compatibility mode, now again, we can see this Christmas tree. But what's cool is with the GSOPS plugin comes a Gaussian splat transform node, for example. And if we use that one to scale up our Christmas tree, we can see everything's working correctly. Same for rotation and scale. And GSOPS comes with a bunch of different features, including deformation, where you could animate a Gaussian splat or twist it or do all kinds of cool stuff with it. So that is up to your disposal. Another cool thing that GSOPS can do, you can use the Gaussian splat source, and you can actually preview the Gaussian splat directly in the viewport, which is pretty cool. Well, that's it for now. Obviously, there will be more features added to this, and as that will happen, I will make more videos. But hopefully this gives you a good comprehensive view of the object parameter settings. I know this was a long video, so if you're still with me, thanks for watching. Please let me know if you have any questions. Feel free to leave a comment or join our Discord, and happy rendering.